Hello, and welcome to Backer Breaks It Down. In this episode, we are looking at solving right triangles. Okay, we're going to focus in this episode on just like finding a missing side or a missing angle, and then the next episode we'll actually do the solving of the entire right triangle. Okay, so you've done this before. It was just in geometry, so it was like 2 years ago. And maybe you did some solving last year in Algebra 2. But a right triangle, okay? Ever since you first heard of a right triangle, one term that you've been familiar with is something called the hypotenuse, right? And in any right triangle, if you locate the right angle is directly across from the hypotenuse, right? Right triangle trig, yeah, the same applies. So the hypotenuse is the side across from the right angle. The other two sides are called legs. And one of these legs is considered opposite, and one of these legs is considered the adjacent side. Which one's which depends on like the reference angle. So like the angle you're working with in a problem. In this little diagram here, that would be angle T, because they've like kind of indicated angle T with a nice little arc mark there. So if angle T is your angle of reference, then that means the side directly opposite angle T, well, that would be the opposite side. And that's how you can identify the opposite side in any of these right triangle trig problems, is to put your pencil on the reference angle, the angle you're working with, or the angle you're trying to find, draw an arrow, and the arrow will point to the opposite side. And then the side right next to it is called the adjacent side. Now, there are three big trig ratios, and those would be sine, cosine, and tangent. And when we were in geometry, we were taught the cute little mnemonic SOHCAHTOA. Remember that? Yeah. Bits and pieces are coming back to you. Yeah, SOHCAHTOA is a cute little way we can remember these three trig ratios. Okay, so it's telling us that sine is the ratio of the opposite over the hypotenuse. So pay attention to your reference angle, draw an arrow, that arrow will point to your opposite side. Okay, the Ka in SOHCAHTOA tells us that cosine is the ratio of the adjacent over the hypotenuse. And TOA tells us that tangent is the ratio of opposite over adjacent. Here's another image illustrating these three trig ratios and their relationship to that angle of reference. A common angle of reference they like to use is theta. Looks like this, like a 0 with a line through it. This is theta. This is a common variable that you will see used for angle measures, okay? So I can use these trig relationships to find missing sides and missing angles in a right triangle. I simply, in the problem need to ask, what do I know, what do I need to know, and how can I find it, okay? And then we can use our calculator to actually find the measurement for us. Speaking of your calculators, you should check your mode right now. There's a button, it says mode, and like the third line down probably says degree, and the degree should be highlighted. And if it's not, then cursor down, cursor over, enter, and it will be highlighted, okay? All right, so in problem number 1, I want to set up and solve a trig equation to find the value of x, right? So I have to be like, what do I know? What do I need to know? How can I find it? And when I'm looking at this problem here, it's like clearly I'm working with this angle. This angle here is 23 degrees. And I know the hypotenuse in this triangle. And I want to know the opposite side. So the side indicated with the X is opposite that angle. So if I were to draw an arrow going from my angle, it would point to the opposite side, and it is. So which trig function relates the hypotenuse and the opposite? So that's going to be sine. So we're going to write a trig equation using sine. So we're going to be like sine of our angle, so of 23 degrees, is equal to the opposite, which is x, over the hypotenuse, which is 24. So this is our initial equation. To solve this, we need to cross multiply. So I've already done that. So I've done the cross multiplying, so 20 sine of 23 times 24, and I have x is equal to that. So since x is all by itself, I'm ready to calculate. And when I calculate this, this is how I got 9.38. So literally on my calculator, I'm like 24 times sine of 23. Okay. Taking a look at another example. What do I know? What do I need to know? How can I find it? Well, I know the side that is opposite the 19-degree angle. And I want to know the side adjacent to the 23-degree angle. So how am I going to find it? That's going to be tangent, because tangent relates the opposite and adjacent. So I'm going to write an equation and be like tangent of my angle, so of 19 degrees, is equal to opposite over adjacent, so 24 over x. And then I can cross multiply. So I've done that. I did my cross multiplying. I'm like, tangent of 19 times x is x tangent 19, and that equals 24. So after I cross multiply, this is where I'm at. And so x isn't entirely all by itself just yet. It's x times tangent of 19. So if I divide both sides by tangent of 19, that's how I can get x all by itself. And then I can calculate 24 divided by tangent of 19. That's how I got the 69.7. Angles can be found in a similar fashion. So if you know the length of any two sides of a right triangle, you can find the measure of one of the missing angle using an inverse trig function. So like here, this is where the notation, see this notation with like the -1 as an exponent? That's the inverse notation. And so this is saying that the measure of angle A can be found by using an inverse sine if I know the opposite and the hypotenuse. Or the measure of angle A can be found by using inverse cosine if I know the adjacent and the hypotenuse. Or I can use inverse tangent if I know opposite over adjacent, but you do need to ask yourself, like, what do I know? Right? So like in this example over here, it says find the measure of angle x to the nearest degree. And so angle x is the angle that I'm working with. And so I'm like, what do I know? And it's like, well, I know the side opposite angle x, and I know the hypotenuse. So that means I should use sine, because sine is the opposite over the hypotenuse, okay? And since I want to find an angle measure, I'm going to specifically use the inverse sine. So that's what we're seeing right here, that the measure of angle x is equal to the inverse sine of 6 over 10. 6 over 10 is that opposite over hypotenuse. Now, when I go to put this into my calculator, I have to be like, well, wait a second, I don't know the angle measure. That's because in order to get that inverse notation on my calculator, I have to use the second button, and then I can use the sine button, and then I can type in my ratio, 6 divided by 10. Right? But I basically have to tell my calculator, hey, I want you to find an angle measure for me. So second sine, 6 divided by 10, and the calculator will give me that angle. Right? So we have to pay attention to the angle we want to find. So here I want to find angle L. And then I have to be like, well, what do I know? And it's like, well, I know the side opposite angle L, and I also know the hypotenuse. And then how can I find the measure of angle L? Well, opposite hypotenuse, that's sine. So in number 3, I'm going to calculate like the inverse sine of, and then my ratio is the opposite over the hypotenuse. Okay. In problem 4, I want to find the measure of angle P. So I'm like, well, what do I know? And it's like, well, I know the adjacent side and I know the hypotenuse. So that would be cosine, right? And so that's what I did in these two problems. Okay, so in number 3, I wanted to know angle L. I'm like, okay, what do I know? I know the opposite. I know the hypotenuse. So that's sine. Sine is the opposite over the hypotenuse. So I'm using the inverse sine because I don't know what the angle is. And then on my calculator, I'm going second sine 8 divided by 9.2, and that's how I got 60.4. In number 4, we're using cosine because we're working with the adjacent and the hypotenuse. So the inverse cosine of 4 divided by 13.6. So yeah, second cosine 4 divided by 13.6. That's how you're getting the 72.9 degrees. So this is how we can use those 3 big right triangle trig ratios of sine, cosine, and tangent to find missing sides and missing angles in right triangles. And that's how Backer breaks it down.